Hey everybody, my name is Omri Klinger, and I will talk today about scaling Meteor apps. Meteor is the best tool I know for building an app. You can make something useful in a couple of hours, but the question whether this infrastructure can support reload is still in debate. I will share today some insights again by taking Meteor to the edge. I hope it will convince all of you that it can scale well. So we will start by building an Uber-like app, a very simple app that returns all the taxis. We start with a naive publication that returns a cursor, that returns all the taxis to the client, and we will start to scale the app from here. The first optimization, very naive one, is just limit the subscription size and the projection fields. We don't want to send all the taxis back. One moment. So meanwhile, I will say that all the solutions that you will see today have been done by people and have been tested aggressively with great performance, sharing subscriptions between thousands of users, with thousands of updates per sec per each client. Okay, so we'll keep it from here. So as you can see, we added a limit to the query options and the relevant field we want to return. We don't want to return the driver name for each of the fields, for example. Next optimization, reuse publication and use indexing. Each publication live query over the DB puts some load on our system, both on the DB because we are fetching the data and the memory because we are keeping an image of the memory being used on the server, and the CPU because we are diffing the fetch data with the image of the memory we keep. So we will try to reuse as much of the publication as we can. So we will ignore patterns like this where the timestamp, the hour ago, is shared between all the clients. It's not being shared. It's unique per client, so the subscription is not reusable. And we will use patterns like this, where the timestamp is shared between all the users, and we can share and reuse the publication. Moreover, we will use MongoDB indexes to get better performance. We should keep in mind that each index over the DB puts some load on the DB as well, so we should use it with caution. So our app started to grow. We put it into the App Store, the Google Play. We gained our initial users, the beta testers. But then, boom. The response time grows. The user gets bad service. The CPU spikes, and we need to solve it. The best solution out of the box, which I'm sure you heard about, is using the Oplog. That's why we added the sort to the query, because in order to use the Oplog, if we use a limit, we should specify sort as well. But what is the Oplog, and how does it change how we handle the data? So the Oplog is a unique special capped collection that MongoDB uses in order to keep all the modifications that have been done to the data stored on your DB. This is the engine behind the replica set of MongoDB that keeps your secondary in sync. And if we are using pooling, for example, if you see there, and we are fetching a subscription of 500 documents, So every 10 sec, this is the default in Meteor, we fetch all the 500 documents. We are doing a diff between them and the current image of the subscription in memory, and sending the client only the relevant changes. The problem with this is that even if there were no changes at all, we are still fetching 500 documents, we are still computing the diff of the 500 documents. Moreover, because it's been done by default every 10 seconds, so if an update occurred in another instance of our app, not the one we are connected to, the latency could be more than 10 seconds till we get the update, not real time. The other way, using the Oplog, at first, we fetch twice the amount of data we would like to return to the client. Half of it we are putting in a data structure of max heap, and the other half, the next in line, we put in a min-max heap. And afterwards, we are just listening to the changes of the Oplog. On each change, we are checking whether it's relevant to our current publication, and if so, we are putting into the max heap, pop the last element, and that way we can handle changes without querying the DB anymore. Moreover, this solution makes us scale very well because we are not putting extra load on the DB. And also, if there are no changes, there is no CPU wasted on doing the diff, and we are always doing a diff of one document instead of the 500 document at the same time. In order to use the Oplog, we should modify our query a bit. We can't use skip in the options. If we are doing a limit, we should add a sort and maybe use an index for the sort. We can use only simple fields projection. I guess all of you are using only simple. The hard ones are the ones that are not supported by Mini-Mongo, like LMH. And the worst of all, we can't use geoqueries like where and near that are not supported over the Oplog. And to allow all of this, we need to use the MongoDB replica set and expose the Mongo Oplog URL.
Nearby?
What?
Nearby supported?
Nearby, no. No geoquery is supported. The next optimization, which is kind of out of the box as well, but I think it's important to talk about, is using LRU cache for frequently fetched data from the DB. If you're using the Alanin roles package, for example, a client that subscribes to a couple of subscriptions at the same time, for example, the client loads a page and subscribes to 10 different subscriptions, and in each you are using the role of the package to think whether you can support this subscription. Going to the DB all the time when being used frequently can put some load on your system. So you can use LRU cache. There is a great NPM package by Isaac, one of the co-contributors of NPM. There is a link at the bottom. So now we feel like we are ready for scale. We uploaded a couple of instances. We feel great. We see the metrics in Google Analytics rise. But then, shit happens. Really. The problem now is that it doesn't matter how many instances we put, each of them spikes. The CPU got to 100% every time we add another instance. Why? Because when using the Oplog analyzes every change to the DB. So when you are write heavy data on your DB, I think I started to feel it around 50,000 updates a minute. All of your several CPUs are being wasted on just analyzing the Oplog. So what can we do? In this case, we can split the DB and get the best of both worlds. We will separate the write-heavy data to another DB, where we will use polling, and the regular data that is being read a lot, but not updates frequently, we will use the regular DB using the Oplog. This is a sample code. The idea here is just that in the top we see how to connect to different DB. And at the bottom, these are the two operations we use in order to use the pooling instead of the Oplog. We disable the Oplog. And the last one is the pooling interval. If we want to change the 10 sec default of Meteor and we want to do pooling once a sec, for example, we use this parameter. But even now, we still have some problem. Our memory being used is too high. And this is due to the merge box. The problem, we can't use regular instances size of 512 mega or even 2 giga when sharing large subscriptions between many users. So we would like to disable the merge box. In 2 sentences, what is the merge box? The merge box is a built-in feature of Meteor that's auto-merge collections, different subscriptions that share the same collection. For example, if I have one subscription that shares the driver name and the driver profile pic, and another subscription that shares the driver name and the taxi kind, it will send the driver name only once to the client. But this feature comes with a heavy price tag, because with a subscription of 500 items, for example, that is being shared by 300 users, instead of keeping in memory just the 500 documents, we will have in memory 150,000 documents, because the merge box keeps a full image of the subscription per each client. So we will need to disable it. This is more like a pseudocode of this feature because it's really integrated into Meteor. But the idea in general that you should bypass the session collection view and send the messages straight over the socket. When we are sending the messages straight over the socket, we are losing the ability to send all the removed documents as the client unsubscribes. That's why we are using here, you can see at the bottom, we are taking all the content of the multiplexer, and as the client unsubscribes, we are going over them and send the removed messages. Next, optimization. So we fixed the memory problem, but when sharing large subscription between many users, we still have problem. The CPU is working too hard. For this, we created the solution of batch publication. This solution is using custom DDP messages, an extension to the DDP protocol. It's an open PR now. You can look at it at site. It will help if you put +1. I hope that it will merge soon to the Meteor core. The extension actually lets you extend the DDP protocol with custom messages that are really important in order to scale you up better. And there is a link here to a Medium post where I explain why we should allow custom DDP messages. But what is batch publication? So the idea is simple. When we are listening to the observer and get the added, changed, and removed messages, instead of sending each message and stringify it and send it to each client, we batch all those messages together and send them as a one bulk to all the clients. That way, it doesn't matter really how many clients are connected to the same subscription, because they all get the same shared data when they are connected to it. In order to implement it better, we added another callback to the multiplexer of MongoDB that's called bulk ended. That way, when we are using the polling observer, we can combine all the added, change, and removed message that have been done during the same operation and send them as one batch. Even when you are using the Oplog observer, it's still useful because when client joins an already existing collection, you just send him the cache data that is already stringified. you will find it unusual, but just stringifying all the messages when you are talking about in real load can take much of your CPU. This is a flow chart explaining the solution. I will pass on it, but you can look in the lecture later. So the benefits of batch publication. Reduce server CPU usage. We compute the messages once and send it to all listening clients. Better ramp time, because when clients joining an already existing subscription, we just send him the batch data. So we can actually scale to very large amount of clients on the same subscription without putting more load, more CPU, and more memory. Optimize client re-rendering. This one is interesting. There is now an open pull request of doing a batch to the DDP on the client side, because re-rendering after each message is not performant. But when doing this solution, instead of re-rendering after each message, in case you have 500 documents, you can re-render once after you analyzed all the documents. And the last one, and the most important, it creates another layer of optimization for Meteor. You can optimize the batch data from JSON graph to subscription level routing, and it's opened a window to the community to create new kind of solution. And especially now that when we are thinking about GraphQL or another solutions, this can be very useful. In the app I'm developing, when we needed real fast updating paste in the number of 10,000 a sec, we use Redis in the backend, and this solution can support it also. And the last optimization I will show today, it's more of a concept, but it will show you how amazing Meteor can scale, is the subscription amplifier. The subscription amplifier is like a middleware for subscription. You tell him, it's a convention, you tell him what the data he should get, from where, from which server, which publication, which options, what the operation is going to do on the stream of data, whether it needs to cache it or not, and to which collection it should publish the data. The idea is that when you are pulling, let's say, 1,000 documents a sec, and you are computing the diff in this space, you don't want to query the DB more than once and computing the diff more than once, but you want to share this data more than once, so you can put layers that will be just middleware over the changes of the relevant data, which is a very nice concept. And here, I will show you a sample of one use of subscription amplifier to scale you up. Let's say we have a subscription that shares 500 documents that are being updated once a sec. And the server that's handling this subscription is being shared, is sharing the subscription with 500 clients. But let's say we want to add another 15,000 clients to listen to this subscription. So instead of connecting them to the instance that is already analyzing the MongoDB data and doing the diff for the 1,000 documents once a sec, we just connect subscription amplifier that each one of them just send the batch data to 1,000 users. That's all for today. Any questions? Somebody?
While having the batch subscriptions, can we have ordinary subscriptions parallelly?
Yeah, of course.
Oh.
Yeah, it's like regular messages actually, but instead of just getting the added or removed. Yeah, I'll repeat the question. The question was whether using the batch publication, we can handle for the same client parallel subscriptions. And of course, all you need to do is do unblock at the first of the subscription, but this one you will need for whatever publication you use in order to use them
No, if I have,
simultaneously.
if I have some publications that are big data but it's constant, and one collection that I get from there very little but different data.
The batch publication is per subscription. So you can handle one of the subscription without batch publication. You can use it whenever you want. Somebody else?
And also, the Amazons, they're not relational database, the second one. Can the DynamoDB, can it be implemented instead of Mongo without the Oplog?
Yes, of course. The idea is that we separate the layers of abstractions. So if you can fetch the Amazon DB and doing the diff over the data, you can support whatever DB you want. We are using Redis for some of the things we want in my project.
Okay.
Thank you. Last one, question?
You have more information about the subscription amplifier? Is it part of the platform, or
It's not yet outside. It's been done on closed network by now. I hope that a couple of the pull requests I mentioned before will be merged, and then we will be able to share more stuff with the community. Thank you.